All right, so 5 is called, it's called multiple angle and product to sum formulas, but we actually are not doing those two topics. Like I narrow it down to just two topics in here, which is double and half angles. That's what we're going to focus on. These are your double angle formulas. And again, these will be given to you on your actual quiz. So the double angles, and this is kind of goes along with the idea of your sum and difference. Let's say you can't find the sine, cosine, or tangent of an angle, but you can break, like 75, but you can break it down into the sum of two angles like we did, 30 and 45. That's one way to find it, right? What if the same thing happens if it's a doubled angle? So if it's in an angle that I can't find because it's not on my unit circle, but if I cut it in half, it's on my unit circle, then I can use these angles. So you'll see these done in a couple different ways. One is that. The second is, we're going to work backwards. And the third is, you're going to see these done with triangles, okay? So these are the formulas. And sine only has one. It is 2 sine u cosine u. Cosine has 3, and you could literally choose between those 3. It doesn't matter which one you use. You can use cosine squared minus sine squared. You can use 2 cosine squared minus 1, or you can use 1 minus 2 sine squared. And then tan of 2u is 2 tan u minus 1 tan squared. If you think about these coming from your sum and difference formulas, what's the pattern for sine if it's a sum and difference?
Sine, cosine.
So sine, cosine, plus, let's say, cosine, sine. Now what happens if these are both the same angle? Because that would be a doubled angle, right? 2 times something would be these are both the same angle. So it would be sine of u, cosine of u, plus cosine of u, sine of u. And this is 2 sine u, cosine u. So this can be derived from your sum and difference angle, okay? That's where that comes from. If they were both the same angle. Ryan? Yes. So if you want to take a screenshot of it, you can pull it into your homework because there's 2 slides like this one and then the half angle. And then so cosine 2u can also be found the same way. If I did cosine, cosine, sine, sine, that's going to be cosine times cosine minus sine times sine, and that's where the first one comes from. And then tangent can be found the same way because it would be tan of u plus tan of u over 1 minus tan u. And that produces that, 2 tan u over 1 minus tan squared, okay? So if I didn't give them to you, you could derive them, but obviously I'm going to make it a little bit easier, and we're going to get given these equations. All right, so first example says find the exact values of sine 2u, cosine 2u, and tan 2u, and it gives you the tangent of u. So this is not my doubled angle. This is my halved angle, and I need to find it of the double angle. So I'm going to use the information given to set up a triangle in the quadrant they give you, which is what this piece of information is. If it's in between 0 and pi over 2, what quadrant is it in? First. So I'm going to go to the right. I'm going to go up. I'm going to put my u in the corner. And tan is opposite over adjacent. Is the missing side here 4? No, why not? Good. So it is a triple 3, 4, 5, but 5 would have to be on your hypotenuse, and it's not. So I'm going to find it doing the Pythagorean theorem. 3 squared plus 5 squared equals the radius squared, or x, whatever, c squared, call it whatever you want. 9 plus 25 equals the radius squared, 34. And r is the square root of 34. So I got to complete the triangle to then use it with those formulas. So I'm going to pull in the formulas so that you have the visual on it. Okay, and the first thing I'm going to find is, I cut off of that, but sine. So sine of 2u equals 2 sine of u cosine of u. So 2 times the sine of u is 3 over the square root of 34. I'm not going to rationalize it because I'm going to multiply it by another square root of 34, so don't waste your time rationalizing it. Times cosine, which is 5 over the square root of 34. So if we've done it correctly, the denominators would be the same, which is why we don't need to rationalize it yet. And I would multiply straight across in the top. 2 times 3 is 6, times 5 is 30. And then on the bottom, square root 34 times square root 34 is what? 34. Can I simplify that? Yeah, it becomes?
18/17.
Good. That's the sine of 2u. Now we're going to do the cosine of 2u. And you can do any of the three. So I can do, if I only had the cosine, I could do the second one, 2 minus cosine squared minus 1. If I only had the sine, I could do 1 minus 2 sine squared. If I have both, I would pick the first, because if you do this correctly, it gives you a like denominator, whereas the other ones you'd have to change one so it has that denominator. So the benefit of doing cosine squared minus sine squared, again, is that the denominator will already be the same. So the cosine is 5 over square root 34, and then we're going to square it, minus the sine is 3 over the square root of 34, and then we're going to square it. 5 squared becomes 25, square root of 34 squared becomes 34, minus 3 squared, which is 9, over square root of 34 squared, which is, again, 34. And I get 16 over 34, which is 8 over 17. With me so far?
Wait, we're finding all of them.
We're going to find all of them. On the quiz, it will only give you one at a time, but for now, you got to be prepared for any of them. All right, so now I'm going to find tan of 2u. And because I have sine and cosine already, I can actually put sine of 2u over cosine of 2u and find it that way. But your quiz is just going to ask you for one. So we're going to practice going right into tan squared 2u. You're not going to have already found sine and cosine to then find tan. So for homework, I would say you could do it that way, but I would practice at least once the tan of 2u. So 2 tan u over 1 minus tan squared u. And the tan was the thing that was given at the beginning. So 2 times 3/5 over 1 minus 3/5 squared. And the numerator is 6/5 over 1 minus 9/25. At 6/5, I'm going to change this so it has a like denominator, 25/5. So 6/5 over 25 minus 9, 16/5. And then we keep change flip. 16/25. Thank you. I was like, that shouldn't have canceled like that. 25th. And then 5 goes into 25 5 times. 6 and 16 are both divisible by 2. This would be 3, and this would be 8. And on the numerator, I have left 15, and in the denominator, I have left 8. And again, if I already had the other two, I could check it by doing the sine of 2u over the cosine of 2u. So if I did that, 15 over 17 over 8 over 17, and we keep change flip it, and I get 15 over 8. But again, on quiz, you're not going to get all three. So make sure you know how to do each of them individually. Questions on triangle, double it. So that's a double angle triangle question. Yep.
Something I noticed for the answers is that aren't things like a Pythagorean triple?
This one is, yeah, it won't always be that way, but this one is.
Okay.
Because basically if we doubled that angle, it might have the same side. Well, no, it's completely
It's
coincidental.
okay.
Yeah, they're not all going to be that way.
I'll have to read it.
Yeah. All right, example 2 says find the exact solution of the equation on the interval, and this needs to be a bracket and a parenthesis. The other thing that killed you yesterday is not reading instructions. Sometimes we didn't do the interval when we needed to, and sometimes we did the interval when we didn't need to. All right, so if you look at this, it's an equation. We're solving an equation, but built into this equation is a double angle. That's also a multiple angle, right? But specifically a double angle. So we're going to use our formulas to expand it. So if I look at the cosine options, and there are 3, why would I pick one over another? So I'm looking at just my cosine options here. Would it matter which ones I pick this time?
Yeah.
Why?
Because it would be easier to solve because you have, so that you only have cosine in it.
Good. I need to get an equation to one trig function, right? I can't solve it if it has sine and cosine in it. The top one has sine and cosine. I then have to replace cosine or replace sine anyways, and the bottom one has sine in it. So instead, I'm going to pick the middle one that has cosine. So cosine of 2x is the same thing as 2 cosine squared x minus 1. I'm keeping the variable the same. This, replace that. Minus cosine of x equals 0. I'm going to put this in order because I've got a cosine squared and a cosine, and I'm going to have to factor. So 2 cosine squared x minus cosine of x minus 1 equals 0. If you want to replace the cosine with an a so you could factor this, you can. You don't have to do this. And this would be 2a squared minus a minus 1 equals 0. And then we're going to factor this. So if I did first times last, because that's how most of you do it, there'd be 2 times negative 1. Factors of that is negative 2. Or sorry, the product of that is negative 2. Factors of that sum to negative 1 would be negative 2 and positive 1. So I replace the middle term with those two. And then I factor by grouping. 2a times a minus 1 plus a minus 1. And the 1 goes here, and I get a minus 1 and 2a plus 1. And then I split and solve. And I get a equals 1, 2a equals negative 1, and a equals negative 1/2. But it's not a we're solving for, it's cosine. So where, oh wait, I wrote on the wrong one. This is cosine. Where on my original unit circle, because it says 0 to 2 pi is cosine 1.
0.
At 0. Where on my original unit circle is cosine negative 1/2?
Third quadrant and fourth quadrant and third quadrant.
Second and third, right? Because it's, so it'd be 2 pi over 3 and 4 pi over 3. Yep.
We're in the unit circle.
Yep.
Are we gonna have to make it?
No.
Are we gonna have like multiple angle and then like also the like double thing, or will we like how do you identify the difference? Is it just like if it has the two?
So because this, I mean, you literally couldn't solve this using your multiple angles because you couldn't solve it without replacing the 2x. So up like a multiple angle question that we can solve would not have one with a multiple angle and one without. It would either have cosine of 2x by itself. Does that make sense?
Yeah.
That you could solve, but together we can't
Okay.
because there's no way to get rid of that multiple angle and still have the other one.
Until it's double angle.
So it will be if it's a double angle, you have to expand it.
Okay.
Yep. But they won't be mixed in. It's not like one's a solve and it's just a multiple angle, and one would be a double angle. Yeah. All right, example 3 says use the double angle formula to rewrite the expression. So now we're working backwards. So I'm going to pull it in again so it's right in front of our face. But what we have here is the result of something that's already been applied using your double angle. All right, so this is kind of like the ones that we did in reverse with our sum and difference. Look at the answer and spot the pattern. So 6 cosine sine. Which of our double angles has just sine cosine? Or cosine sine, because the order there wouldn't matter. Cosine does. And the equation is 2 sine u cosine u. So how do I rewrite this? Oop, not scratch through. How do I rewrite the question So that part of it would be 2 sine u cosine u.
Three,
I make this 6 is the same thing as 3 times 2 sine x cosine x, right? And then 2 sine x cosine x is sine of 2u. So this is 3 sine of 2u. So you're rewriting it to, like, go backwards, to build the double angle into it. So you got to spot the pattern. If it's just sine and cosine, obviously it's sine. If it's cosine squared and sine squared, it's cosine. If there's a cosine squared and a 1, it's like, so you might have to factor something out, but one of those patterns will arrive. And obviously if it's tangent, it's tangent. You just got to figure out how to rewrite it in terms of that tangent. Questions on that one? All right, now we get, these are the second set of formulas. So we did double angles, now we're doing half angles. Again, you could take a screenshot of this. Again, this will be given to you.
That's not on our note.
So half angle formulas are for half angled. So again, let's say there's something like find the sine of 15 degrees. And we can't find the sine of 15 degrees, but if we double it, we would get 30 degrees. We could find the sine of 30 degrees by using one of these formulas. So in these examples, what you will have is already halved, okay? And then it will say find the sine, and you're picking either plus or minus, which we'll talk about in a minute, square root of 1 minus cosine of the doubled angle over 2. If it's cosine, it's plus or minus. Again, we're going to talk about that in a second. The square root of 1 plus the cosine of the doubled angle over 2. And then tangent, you can choose between those two. 1 minus cosine over sine, or sine over 1 plus cosine. And tangent, we don't have to worry about the sine. It figures itself out, okay? On the bottom, it says the signs of, literally like the positive, negative signs, of sine u over 2 and cosine u over 2 depend on the quadrant that the original u over 2 angle lies in. So if I use the example of 15 degrees, okay, I cannot find sine or cosine of 15, but I'm going to double it. So my doubled angle is 30, and 30 becomes the u. So 30 is what we use for u because we're actually finding the sine of 30 over 2, which is 15. And when we find the sine, we're going to use this whole formula, but then at the end, to figure out if it's supposed to be positive or negative, we go back to the original angle, which in this case is 15 degrees. Where is 15 degrees located?
Over 6.
Well, 15 is not in, it's not one of my special angles, but what quadrant is it located?
First one.
Sorry, it's in the first one. And what is the sine of sine in the first quadrant? Positive. So I would pick the positive there. So if I go to cosine, I'm going to try to do it again, right? Cosine, I would plug in all this information using 30 degrees as my u, and I'll get a value. And then at the end, to figure out if it's positive or negative, I go back to the original angle. So 15 degrees would again be in the first quadrant. And in the first quadrant, the sine of cosine is what? Positive. So I pick the positive. If my original angle was in the second quadrant, then my sine would be positive, but my cosine would be negative. Does that make sense? If my original angle is in the third quadrant, they're both negative. If my original angle is in the fourth quadrant, then the sine is negative, but the cosine is positive. So, I mean, I'm going to work through an example, but that's what this means on the bottom. Okay? The u over 2 is your original angle. You have to pick if it's positive or negative. Yep.
You have to move it into like radians.
No. No, because you'll use 30 degrees, and 30 degrees is on your unit circle.
Used to like determine where in the quadrant it is.
To find the positive or negative sign, you have to locate the original. Yeah. But then to actually find the value, you use the doubled angle. So they look like this. It says use the half angle formulas to determine the exact value of the sine, cosine angle, and of the angle. What's weird is it's saying use the half angle formulas. We're going to use the half angle formulas, but the first thing we do with that angle is double it. Because we're going to use the doubled angle in the half angle formula. That's when it's weird, okay? But we can't do anything with 75. And if we cut 75 in half and we try to use the double angle formulas, it won't work. because 75 divided by 2 is not on my unit circle, okay?
150 over 2.
But that wouldn't be on your units. You'd have to find the exact value. Didn't you know what I'm saying? Oh, no, we are doubling it. You are getting 150. I'm saying you wouldn't cut it in half.
5 over 6.
All right, so first of all, I'm going to locate where these are. 75 is where on my unit circle? First quadrant. So what's going to be true about the positive, negative signs of sine and cosine? It's a positive sine. It's a positive cosine. I don't need tangent because it works itself out. You don't have to figure that one out. Then everything else after this, I'm using 75 times 2, which is 150. So again, I'll bring in the formulas so they're in front of our faces. You have to, yeah, which again, quiz-wise you won't, but you could get any one of the three, so we're going to practice them all. All right, so the first one is the sine of 150 over 2, which is the sine of 75. That's what we're finding. And our u is the 150. We said it has to be positive, and it would be square root 1 minus the cosine of 150 over 2. And then I would go to my unit circle, and I would find 150, and 150 is where? Second quadrant. Yep. At the over 6 there. So it's negative root 3 over 2 and 1/2. And the cosine there is negative root 3 over 2. So I do minus and negative root 3 over 2. Over 2. And all that's underneath the radical. So then this becomes plus. I have to find a like denominator in the numerator. So 2 over 2. And I get the square root of 2 plus root 3 over 2 over 2, because it's still in the denominator. Then I flip this. So 2 plus root 3 over 2 divided by 2 means I'm going to multiply by 1/2. And I get the square root of 2 plus root 3 over 4. And I'm actually going to leave the numerator as the square root of 2 plus root 3. But my denominator is going to become 2. Because it's the square root of 4. So this is the sine of 75. And we're keeping it positive because we said 75 is in the first quadrant, so it would be positive.
Wait, you said you divided by 2 and then you just...
Well, the original question is divided by 2. We double it to plug the value in for cosine.
Oh.
All right, now cosine. The only thing that changes is it's 1 plus cosine to u. So I literally, if I have sine already, all I have to do is change the sign from positive. The one, whatever's there, I have to flip. But if I go directly into it, I know it's positive because it's cosine and it's 75, which is in the first quadrant. And this is 1 plus the cosine of 150 over 2. This becomes 1 plus a negative root 3 over 2 because that's what our cosine is at 150. So this becomes 1 minus root 3 over 2 over 2. Repeat that whole process, give this a like denominator, and I get the square root of 2 minus root 3 over 2, all over 2, and then I flip it. I get the square root of 2 minus root 3 over 4, and my numerator will stay under the root, but my denominator becomes 2. Yeah. From the bottom. So we were dividing by 2. Instead of dividing by 2, we multiply by 1/2.
Okay.
And then 2 minus root 3 times 1 stays, and 2 times 2 becomes 4. And then they're both under the root. So you can split the root if you need to, but they would both be square rooted.
Oh, okay. I didn't. Isn't it the cosine of 75?
Oh, yes, sorry. This is cosine. Thank you. All right, then we do tangent. Tan of 150 over 2 And we can pick either one, so I'm going to pick the first one, 1 minus cosine u over sine u. Okay, so 1 minus the cosine, so which is a negative root 3 over 2. And then what's the sine at 150? 1/2. So I get a like denominator. This would be 2 over 2. This becomes plus. And I get 2 plus root 3 over 2 over 1/2. And then I flip it. And the 2's cancel. And I get 2 plus root 3. And that's the tan of 75. And tangent, we don't have to pick a sign. Because you're involving both the sine and the cosine, the sign will fix itself. It's the other two that you have to determine the sign of. Questions on that? So obviously it's a tedious process. You'll only need to do one of those 3 for your quiz, but it's gonna ask you for multiple ones in the homework. Yeah. All right, so what changes with B is it's just in radians, okay? It's still going to tell you what formulas. It literally says use the half angle, so hopefully it tells you what you're doing. Where would 5 pi over 12 be on my unit circle? What quadrant? Is it in between 0 and a half, and 1, 1 and 1.5, or 1.5 and 2?
0.5.
It's in between 0 and a half, right? 6 over 12 would be your halfway mark, yes? So what quadrant is this in? It's in the first quadrant. So my answers are going to be a positive sine and a positive cosine because of the location of the original one. Now, everything after this, we have to do the doubled angle. So we're going to multiply by 2 because 5 pi over 12 is not on my unit circle. So I say times 2, and I get 5 pi over 6. So my u is 5 pi over 6. So I'm going to do sine first. Sine of 5 pi over 6 over 2, which is positive square root of 1 minus the cosine of 5 pi over 6 over 2. And then I'm going to do the cosine of 5 pi over 6 over 2, which is also the positive version of the formula, 1 plus cosine of 5 pi over 6 over 2. And then I'm going to do the tangent, 5 pi over 6, I don't know why I did it that way, over 6 over 2, which is 1 minus the cosine of 5 pi over 6 over sine 5 pi over 6. So now I would go to the unit circle. Again, you'll have your unit circle. I would go to your unit circle. I would find 5 pi over 6, and it's the same coordinate point that we just used. Negative root 3 over 2 and 1/2. So all of these questions are going to have the same answers. Do I need to redo them? Because all of this is the same as this. 150 is the same as 5 pi over 6, okay? So the biggest thing I would say that could be very costly here is the sign, because guaranteed your answer is going to have multiple, like the positive sign of it and the negative sign of it. And you have to know it's based on the original location of the angle. So from the get-go, I do this. Like, okay, this original one is in quadrant 1. That means that both my sine and cosine are positive. If you have a multiple choice question, that means get rid of everything that's negative, because already I know that part has to be positive, okay? If it's sine or cosine. If it's tangent, you obviously have to wait. Question so far?
The last part you said.
So you're choosing if it's positive or negative based on the original location, right? So if my original angle is in the first quadrant, then sine and cosine are going to be positive, right?
Right.
So if I have multiple choice question with multiple choice answers, and there are negative answers,
Like a negative in front of them?
correct.
Like a negative in front of the top
Of the square root, correct. Then I ignore it because it can't be negative
Right.
because it's in the first quadrant.
Oh, I get it.
Okay, so it says determine the quadrant in which u over 2 lies. Find the exact values of sine u over 2, cosine u over 2, and tan u over 2. So if I have to find where u over 2 lies, then I have to first find where u lies. So we just said this would be between 3 pi over 2 and 2 pi. So u would be in the fourth quadrant. right? Now, what happens to angles that are in the fourth quadrant if I cut them in half? Find an easy one in the fourth quadrant. Give me something like a nice round whole number in the fourth quadrant.
They're all 300.
300. Good job. 300. If I cut it in half, what happens?
150.
I get 150. Where's 150?
Second quadrant.
Second quadrant. Okay. If it was 320, I cut it in half. 160. Second quadrant. Any angle from the fourth quadrant cut in half. If it's in the fourth quadrant, u over 2 is in the second quadrant.
Does anything in the third quadrant go in the first quadrant?
No. So now go to the third quadrant. If a variable or if a value is in the third quadrant, again, pick a nice round whole number that's easy to divide by 2.
210.
Or 200.
105.
200. Sure. What happens when we cut that in half?
Second quadrant.
It also goes to second quadrant. So anything in this one also goes to second quadrant. So u over 2 also goes to second quadrant. Quadrant 2. If I'm in the second quadrant and I cut it in half, where's it go?
First quadrant.
First quadrant.
Or like this.
I mean, where else is it going to go, right? First quadrant, cut it in half, where's it going to go? It's going to stay in the first quadrant, okay? So anything in the bottom, when cut in half, goes to Q2, and anything in quarter 2 cut in half goes to quarter 1. Now, based on that, where would u over 2 be if u is in my fourth quadrant?
Second quadrant.
So this is in my second quadrant, which means what should my sine be? Positive, and my cosine should be negative. Does that make sense? Oh, okay. All right, now I have to actually find the values, build my triangle, and then find the values. So this is the original one is in my fourth quadrant. I go forward, I go down, I put u here. Tangent is 5 over 12, but it's negative. How do I know which of those gets the negative? Why does the 5 get the negative? Good, because the y is negative, not the x. The x is positive. What's the radius?
13.
13. That's one of your triples, right? And it's always positive. Always. Okay, so now we're doing our half angle. Okay, so if I want to find the sine of u over 2. First of all, we said sine would be positive. I get the square root of 1 minus the cosine of this triangle, which should be 12 over 13, over 2.
Wouldn't the cosine be negative? So would it be added to them?
The cosine, no, but I'm using the cosine of u. So cosine of u is positive.
Oh.
Yeah. Then I'm going to do cosine of u over 2. And this time we said cosine's negative, so we pick the negative. And it would be 1 plus, because that's my formula, the cosine of the original triangle, which is 12 over 13, over 2. And then I do tangent of u over 2. And I get 1 minus cosine, which is 12 over 13, over sine, which is negative 5 over 13. Now I'm going to go back and simplify them. So all those ones become 13s over 13s because I have to give them a like denominator. So I get the square root of 13 minus 12, or 1 over 13 over 2. I flip it. I get the square root of 1 over 26, which is 1 over root 26. And we rationalize root 26 over 26. It was positive because it's sine. Questions on that one? All right, then I go to cosine. So again, this is 13 over 13. This time it's plus 12, and there's a negative in front of my square root. So it's 25 over 13 over 2. Flip it. I get negative.
Is that 4 over 2 or u over 2? In the way we get.
This is a u.
Oh, okay.
Yeah. 25 over 26. I get square root 25, which is 5, over square root 26, which gets rationalized. 5 root 26 over 26. And it's negative because we said u over 2 would end up being in the second quadrant. And then our last one is sine. Again, the 1 becomes 13 over 13. I get 1 over 13 over negative 5 over 13. 1/13 times 13 over negative 5, and I get 1 over negative 5. And that's tan 2u. I mean, u over 2. All right, example 7 says use the half angle formulas to simplify the expression. So the first thing we have to do is figure out what pattern it is, again. So like if it's 1 minus cosine of something, which of the trig functions is it? Sine. So I know I'm going to do sine, but I need to figure out what my u is. So sine u over 2, this value, whatever we normally get, we double when we put it in, right? Like when we found the sine of 75, we doubled it to put it in, right? We put 150 in. So if I have to double something to get to 6x, what am I doubling? 3x. So this is the sine of 3x. And you can always kind of work backwards. Like if you had multiple choice, you could always see if it said sine of 3x, I would double it to get u. So it would be it would be cosine of 6x, that kind of thing. You would not have a graphing calculator. I actually did not put this question on your quiz, but it is on your homework, okay? And we need to review the solving of equations. So I need to, in my equation this time, has a half angle. That half angle is sine x over 2. So I'm going to replace it with this. So I would get square root of 1 minus cosine u over 2 plus cosine x equals 0. So I've replaced my sine of x over 2 with the square root of 1 minus cosine x over 2. How do I get rid of a square root? Well, first I got to move this sucker over here, right? They have to separate. So I'd get 1 minus cosine of u over 2 equals negative cosine x. Now this could have been plus or minus, but what happens when I square both sides? That becomes positive, so the plus or minus doesn't really matter. It's going to go away. And I get 1 minus cosine of u over 2 equals cosine squared x. Now I got to multiply by 2. And I get 1 minus cosine u equals 2 cosine squared x. And now I'm going to get everything to one side. And I'm going to factor. I switched my variable. From the beginning it was an x, right? Yeah.
You did it because you looked at the form.
Yeah. And then I'm going to factor. I'm just going to do trial and error, but you could have done first times last. This would be positive 1 and negative 1. And then we split and solve. Cosine of x would equal 1/2, and cosine of x would equal negative 1. And where on my natural unit circle is cosine 1/2? Where's the x positive 1/2?
Quadrant 1 and quadrant 2.
Okay, where in quadrant 1? It's quadrant 1 and quadrant 4, but yeah. Pi over 3. And in the fourth quadrant, 5 pi over 3. And where is it, negative 1? Pi.
Yeah. Wait.
I feel like LeBron.
Because negative 1, right, left. Yeah.
Could I see the full
Mm-hmm.
Wait, so when you square something, it gets rid of the plus or minus?
Yeah, no matter what sign that was, it would have become positive.
Okay.
Yeah, there's still one more, but go ahead.
I'm sending her waterfall sack.
Mm-hmm. All right, example 11 says use, oh wait, this is the one we